Good morning. I would like for us to shed some light and talk about Victron systems and why I feel this is the best setup for any camper or an RV setup. Let's talk about the theory side of things for you to have a better broad understanding. Let's talk about the technical and practical connections, and of course the VRM Portal and VictronConnect App. I hope this serves to inform you as always. I truly appreciate you taking the time. Let's go. Let's talk AC systems, right? AC. In this case, we call them AC loads, right? AC loads. Let's just zoom on that. Now, you could have a stove, you could have a kettle, you could have an iron, you could have a toaster, a fridge, and the list goes on. In our South African standard, it's 230 VAC with the rated power. Let's just try this base, for instance. Look at this. This is rated at 220 to 240 at a power consumption of 1850 to 2200 watts. You see that? This is an AC system. And many other AC systems. You could have a TV and so on and so forth. But these are called AC loads, right? Now, let's talk DC loads, right? Now, DC loads could literally be the same things. You do get a kettle, a toaster, a fridge that runs on DC. So, in this instance, I'm going to write fridge, or many other DC loads. It could be, I want to think of something practical, an air compressor. It could be a DVR, it could be lights. The rule is that in my system, this is a 12 volt DC load with a particular rating in watts or amps, right? Now remember, you could have a 12 volt DC, 24, 36, 48 and so on, but in my case it's a 12 volt DC system, right? Now, how do you supply, let's just zoom out there, that's fine. How do you supply AC systems with power? How do you supply DC systems with power in a camping setup, right? In a camping setup, you have a battery, right? A battery. And in my case, it's a 12 volt battery at 400 amp hours, right? So, because a battery is a DC source, it can literally just supply DC appliances without any conversion. 12 volt straight, supply it. And whatever appliance is there will draw the power based on the amp hours. But you cannot supply DC loads with AC loads with DC load. You have to invert that power, right? So we introduce an inverter, right? And the inverter should be rated at the total load of your appliances. So if the stove, the fridge, the iron, the toaster, and all this makes up 1000 watts, just figuratively speaking, you must ensure that your inverter is either above that number, but you cannot run all this 1000 watt load with a 500 watt inverter. It will be impossible. In our case, we've got a 1200 watt inverter. Now the inverter converts the DC current into AC current or AC power so that it can supply. So from the same battery, we supply DC load. from the same battery. We are trying to supply AC load, but we first have to invert that power so that they also get supplied. Now, how do we make sure that we replenish and restore the power lost? Because all the DC systems are drawing power from the battery. All the AC loads are drawing power from the battery through the inverter. It means we need to charge this thing, the system, right? We need to charge it. Now, there are two ways to charge it. There are three ways in a camping setup to charge it. Well, there are many ways actually, but in my case, I've got a DC to DC charger, which takes power from the car's alternator, the car's power plant, and supply power here to keep this battery at 100%, right? Then you've got solar, right? You've got your solar system there, which in this case will take the sun energy and supply this battery. And then another way is through the grid. Grid would mean grid power, shore power, ESCOM. Now, this ESCOM is an AC supplier. DC to DC takes DC and supplies DC. MPPTs, charge controllers, take the sun, convert to DC. So you can literally take these two directly to the battery, but you can never take an AC grid power and charge a DC system. It must first go through the inverter, and the inverter will convert that AC power to DC to charge it, right? So you've got 1, your grid, 2, DC to DC, 3, the sun. Now there could be a generator, there could be wind energy sources, there could be many other sort of ways to replenish or charge the battery. But in our case now, just to simplify things, you have got your AC loads, your DC loads. DC loads draw power from a DC battery, and then this is charged by a DC to DC charger and an MPPT charge controller, right? And this converts energy to an inverter, and the inverter will supply all AC loads, and through the grid the grid sometimes bypasses and just keeps supplying the AC loads so that you don't strain your inverter and battery, and then you grid power. So ESCOM goes in, supplies power as it charges the battery, but also supplies your AC loads because this is an AC supply. DC to DC will take DC from the car and charge your DC battery 12 volts, and then MPPT will take the sun, convert that to DC and charge your battery. So your state of charge is almost at a particular percentage, 100% in our case, as we desire. As the battery drains, this system will reload it. Now, in the midst of all this, there is a device called a Cerbo GX. Now, there could be an Ecranum, it could be a Venus GX. It connects all these systems together. All these systems, it connects them and becomes the master brain that monitors how much power is coming from the grid. For instance, let's say your state of charge is almost at 100%. Now, the Cerbo needs to read that value and tell the MPPT, the DC to DC, the grid that I don't need power anymore. The battery is charged up. So lower the current that comes in, lower the power that comes in, allow the grid to bypass, create scheduled chargers, safe every day from such and such a time, do charge at max, go bulk charging, float charging, absorption, and so on. All this is decided by the Cerbo or any GX device. If the battery is, say, maybe at 20%, we need as much power to reload our state of charge. So it will draw all the power, 50 amps in our case, from the grid, all the power, 50 amps from our DC to DC, all the power, 70 amps from our DC to DC. All this power has to be thrown into a battery that can handle such current so that it can get to a higher state of charge in a short space of time. All that's determined by the GX. Also, how much load are we drawing from the AC systems? How much power are we drawing from the DC systems? So all this is controlled through the Cerbo. Now the Cerbo can either connect through you can connect it through Bluetooth, you can connect it through Wi-Fi, you can even connect it through a GX Touch 50 or a Touch 70. A GX Touch, these are LCD screens that draw power from an HDMI from the Cerbo, right? But the Cerbo controls and runs the whole system and determines how much power is drawn where and how to keep the battery charged up. All right, so let's go through the practical elements of this. But before I get to that, in my case, I've got the sun, right? The sun goes through a solar panel. The solar panel, this is a JA605. The solar panel goes into an MPPT, right? The MPPT sends the power to the battery, right? Now this, I just want to put the Cerbo here, Cerbo there. Now I have got a DC to DC. In my case, it's an Orion XS 1250. That means 12 volt in, 12 volt out at 50 amp. This is an MPPT 150 volts at 70 amps, right? Now this MPPT connects to the Cerbo through a VE direct port, and then the DC to DC also supplies the battery, but also connects to the Cerbo for monitoring. This is for communication. Thereafter, there is a MultiPlus, right? This also connects as a VE bus. Now this also connects to the battery. This is a 1250, 12 volt in, 1200 watts out at 50 amps. All right, that goes to the battery as well. And thereafter, because my BMS in the battery cannot communicate with the Cerbo, I've introduced a shunt. This is what helps me maintain and see the state of charge in my system, right? But in a perfect world, you would rather get a battery bank, a Victron battery or whatever brand you choose that allows to communication directly with your VE systems, which in this case would be your BMS or your VCAN. So this is basically how the system works. All right, this is your Victron. The sun goes in, DC to DC goes in, grid goes in, all monitored by the Cerbo. That can be monitored via Wi-Fi, whatever, and then yeah, that's how the system works. Let's go through the practical side of things. I would like us to go through the Victron systems in this camper. This is the nose cone, and I was able to compactly fit everything in here. Inverters, sensors, compressors, DVRs, Wi-Fi, and the lights. Alright, so let's start from the front. There is a fan, extraction fan here with an LED light. I can either power it, it automatically powers up through the temperature controller over there, or the Cerbo, or a remote. I can press that and then it will run the fan. Press that to cut it off. The reason why I want to run it through the car keys is because not only do I want this to extract heat from the nose cone. Sometimes I'm driving in a gravel or dusty road, and this is to eject or reject all the dust that may try to go into the system. So remember, this pushes out heat, but also there is a backup fan over there that's inside the main house or the main trailer. So that also pushes clean air this side. That has a filter. So I'm hooking also through the seals. As soon as you close it up, you can see it's got some bed marks over there that shows that it's creating a good seal. From the fan, you've got an auxiliary output that comes from the inverter. So currently this is running the Snowmaster fridge here. There's also an Angel fridge at the back. Actually, let me show you that, because it's got a DC and it's got a DC. There we go. So it's got a dual input. It's running now with a dual input of AC and DC, 12 volts to 30. Alright. And there's the water heater, water tank on the other side, auxiliary tank. Okay. So coming back to the car, the nose cone. Below the auxiliary output, there is a grid input that's running a thick 2.5 mil cable. This brings all grid power into the nose cone, and then above that there is a compressor. I see there's a compressor there. Let's power it up, and that's just to inflate and deflate tires. Above that there's your battery bank. Still waiting for an enclosure for this, just to give it a nice, neat and more decent, safer. Just DIY this wood just to protect the terminals, but I need something better. I've also drilled holes here for testing. Once in a while I want to see if the cells are balanced, manually testing each cell. So I just dip in my strobes there, and they are pointing to the terminals. On top of that there is a shunt, 300 amps. That's got a VE direct port. We'll talk about that shortly. So this takes the main negative terminal through a bar to the negative of the battery. This goes to the negative of the BMS, then further the bus bar. So there are two 35 mil cables bonded together to create a 70 that goes through a circuit breaker. Now this circuit breaker is labeled 250 amps, and that's a lie. I bought these fake breakers, I don't remember when, tested each and every one of them. I had a 300, I had a 400. I was influenced by the fact that the battery bank is a 400 amp. So I had a 100, 200, 250, 300 and 400. And they just label them like that. It's not true. When I tested, this goes at 180 amps, and then it trips. 180, 190, it trips. So pay attention to the terminals. You know, you need the ones with the bigger terminal. That's the original. That's the big deal right there. These are just fake. So don't mind 250 there. It's not true. From there, the power goes into, of course, the bus bar. From the bus bar, the positive bus bar and the negative bus bar. There's the temperature controller. This is to monitor the nose cone. To monitor the nose cone environment, the sensor is right over there. And then the other sensor goes just behind the MultiPlus there. And the other one is behind that MPPT over there. And then from there, we've got our main charge controller. This takes power from the what you call this, Anderson plug, and then sends the PV power to that charge controller, which charges at 70 amps when I plug. So that goes to the JA. So the 70 amp, I only achieve that when I plug 6 panels or so of this JA. These are 605s, but I usually carry one to a campsite. So that comes into the MultiPlus, sorry, the MPPT, and then that connects with two 35 mil cables to the bus bar. So that is meant to charge the 400 amp hour at 70 amps. Keep that in mind. Above that, there's an Orion XS 1250. This is a very tiny unit, and it does work. It does. It's also got a VE direct port, just like the shunt. and also the controller, the MultiPlus charge controller. So this charges the battery at 50 amp, and then next to that there is the MultiPlus 1250 that charges the battery at 50 amp. So there's 50 amp charging power plus 50 amp, that's 100, plus 70 at max with all the panels, that's 170 amps. That's what made me decide or make a decision on going with this. All right, remember, this is just fake. I'm still waiting for the original brand, but I couldn't stop camping whilst I wait for the delivery. In front of the MultiPlus, I just put double-sided tape and put up a Xiaomi repeater. This brings internet into the camper, the nose cone. So I've configured it in a way that it's just a repeater. One output goes into the DVR that's under there, and then another RJ45 supplies the Cerbo with internet. I did not want to use the Wi-Fi in there. On top of, next to the MultiPlus is my DC fuse box. Then obviously that supplies the compressor, the water pump at the back, interior lights, that'll be that, and the ones inside the trailer. And then there's the rear lights. This is all the lights in the roof tent. Radar is the DVR, kilowatt is the battery displayer and the Cerbo, and then just a spare fuse that didn't use it. Auxiliary output. This is I've run a 16mm cable to the back right there. Alright, this is that fuse. So I've got a plug that goes in there and gives a cigarette socket. What do you call that? Cigarette lighter socket. That goes into the auxiliary. The DC output is okay. Let's go back there again. Right over there. Right. That's the DC output, just an auxiliary output. I use that for the shower. Got a portable shower, so because the shower is on the other side of the camper, that's why I usually plug. Then there's the fan override, which is the extraction fan, and the roof lights are the lights on the main roof tent. So at the back, when you stretch out the tent, there is the awning side, there's lighting there, that's rear lights, and then inside the camper, that's roof lights. Now all of them are fused. I have double fused the let me just disconnect the DVR and show you how I double fuse. There we go. So this is the DVR power, but along the line I added another fuse. This is 1 amp. I once blew a DVR because of the 2.5 drive that was in it, but I've since installed a 2.5 SSD. So I've put a 5 amp there. I think it is a 5 amp. Yep, I put a 5 amp there, and another 5 amp at the back. Alright, so let's go through the Victron systems. Alright, this is the brains of the entire system. The 3 VE direct ports connect the VE direct from the Orion, the VE direct from the MPPT, and the VE direct from the shunt. My DIY battery cannot communicate with this BMS. It's a DALI. I need to downgrade and install custom-made firmwares and stuff. I just didn't want to go that route. The only thing missing here would be for me to introduce a wireless HDMI transmitter. So plug it here, throw it at the back. So I shouldn't, as of now, let me show you. I think it's an Amazon 8 something, Fire something 8 HD, whatever. So I've downloaded a Victron app that allows you to bypass the entire operating system of the iPad, or sorry, the tablet, and overrides that with its own system that monitors all GX devices. It could be a Cerbo GX and a Chrono whatever GX device you have, and you can monitor it from there. So the reason this works through the Wi-Fi, but I needed an HDMI output so that when I watch TV, I've got a dedicated projector. I can always view, especially temperatures and stuff, because that's my interest. If you see there's levels. I can check the tank sensor. Let's just go there. There's the tank sensor, there's the environment, all the temperatures, the battery temperature, the DVR, the inside the nose cone temperature and stuff. So overview, I can go brief and it will show me what's coming from the grid, what's coming from the car's alternator, what comes from the solar panels, and the state of the battery, the water tank level, and the consumption AC and DC, right? So right now I'm drawing 140 from the grid. This is to run the fridges, I'm sure, and it's on float charging because there's nothing really draws. I think I'm drawing about 0.2 amps on it. So there's the solar yield, which shows the solar output. It's not connected now, it's on 0. The alternator, that's the MPPT, the DC-to-DC, that's off, and they both charge the battery. And then there's your DC loads and also your AC loads, right? So basically this is how the Victron system is being monitored, and I can monitor this from anywhere. With regards to the tablet, I need to be within the Wi-Fi, but with regards to the VictronConnect app, I can be literally anywhere and I'd still be able to view the environment. So that's basically it here. That charges the battery at 50 amps, 70 amps. That's to be the solar, to be the car's alternator, through the grid. And then that inverts like DC to electricity. That supplies the the distribution board to all the electrical supplies in the nose cone. Yep, that's basically it. I'm pretty much happy with what would I upgrade, or what am I planning to upgrade. Obviously they get an original branded something reliable on the circuit breaker. I'm not happy with that. In future, just get a nice, come on, it's all cheapy and stuff, but it works. Compressor I'm happy with. The supply I'm happy with. That supplies only the induction stove and also the quick water heater. That's basically it. Here I'll just add a HDMI output, and then the rest I'm happy. I really am. I wouldn't change a thing. Thanks again for watching. I hope you did pick up a thing or two. I think a part of me forgets something I want to say, but I can't think of it now. But anyway, thanks for sticking through this part of the video. Truly appreciate it. Let's go through how these Victron systems really work. I don't think I explained everything on the Cerbo. So the Cerbo has a network cable that obviously comes to the router. Behind that is the VE bus, that's the inverter itself, and there are 3 VE direct ports. That's one for the shunt, one for the MPPT, one for the Orion. This is what makes me see this application of devices on the VictronConnect app. Next to that is a USB port that connects, that powers the router. I'm just drawing a 5 volts from there. Behind there's just terminators that usually work with VE CAN devices, nothing connected here. My BMS doesn't support this, so nothing plugged on that end. At the bottom I've got water sensors, temperature sensors, and one relay to power the fan. And this is my Sentry receiver. This helps me use Centurion remotes to power the fan. But other than that, that's it. I'm happy with the temperature of what happens here. Everything is, I'm happy with this. It does what it's supposed to do. It works. That's what matters. I'm happy with this. I really am. It works. That's what matters. So I've got my CCTV cameras. That's 4 3K cameras. I'll give you the brand name now. I've got an Orion XS 12, an MPPT, a MultiPlus, a MultiPlus, a Cerbo shunt, and the wiring. Thanks for watching. And all that compactly fitted and squeezed in there, right? This sticker, I'm looking to improve it. I don't like these two blank sides there, so I have rebranded. Let's just go through it. Just need to make time. I've redesigned something that would be far much bigger to fit on the entire mainspring. Just to give it, there we go, something bigger. You see, that's much better than that smaller one. But yeah, we'll go through all this another time. This video was just to talk about the Victron systems. Take care. So I want us to talk about the VRM Portal and also the VictronConnect app. So let's start with the portal. You are going to go to vrm.victronenergy.com and create an account or sign in. This is where you land, right? First on your right is product review, product news, firmware updates, and whatever upcoming devices are there. You'll find that all here. If you look just somewhere mid-section, you'll find my installations, favorite installations, and currently viewed installations. I've only got 2 installations, but let me show you how you edit on favorite in case you've got a bunch. You're going to go to installations, select a particular installation, and on the right side there is add to favorites. When you go back home, you should find it in favorites, right? Secondly, it's where you add your installations. So all your GX devices, be it Cerbo, Victron, Venus, MultiPlus 2 GX, all of them, you find all that here. Remember, when you buy a second-hand GX product, it remains bound on the previous owner's account, and you cannot edit here unless they give you access or delete it from their end. How you do that? You can always ask them to go to installations, select their installation, go to settings, general, scroll down, and find delete installation. Only after it's been deleted from the old user can you be able to edit on yours. All right, so that's where you add your installations. Third part, the most important part, the third part is the entire list of your installations. I've only got my home system and my trailer or the camper. So let's go through the camper. And as soon as you click on a particular installation, this is what you are listed with. I recommend that you go to device list first, scroll down, and update firmwares. So what the system will do is log into the current setup and look for updates. It's just going to take some time scanning there. There we go. So all my systems are up to date. You see there's the Cerbo, the Shunt, the MPPT, the Orion, and the MultiPlus, right? And they are all up to date. Now you can get more info, just click that and list what other updates and firmware are available at the time, but that's all in device list. Whilst we're here, let me just go through. The gateway is your Cerbo, and then you can click there to get more information about that Cerbo, the serial numbers, IP addresses, and so. Secondly, it's my MPPT, same thing, you can get the info there. the Shunt, same thing, you can get the info there, serial numbers, and so on, and remove them from your system individually. You can do that. This is where you delete a particular, you could still delete your what do you call it, from your device list. You can delete them completely to move it. For instance, I'm not using this anymore. Delete. I had switched my Orion into battery to battery charger, so it added it as a different device. But everything is here: the nose cone fans, monitors, and battery temperatures, digital input. This is my water tanks. Where's that? This is my water tanks. You can delete all those sensors and stuff, but this device list, rather, I'll show you where you view them from your VictronConnect app, but this is where you manage them. How do you configure, especially your VE bus systems, your MultiPlus, and so on? You are going to go to remote VE configure. You can always use your USB to configure this, but I always prefer the remote method. You go to remote configure, download. So what that's going to do is download the settings of the MultiPlus, right? It'll compact everything into one thing, download it. Thereafter, you will open it, configure the files individually, your charge tab, your grid systems, all that, the settings you want to run inside your MultiPlus. This is where you do it. It's just taking forever to download. Just a second. So this is delaying because it has to go into the MultiPlus, pack everything in one package, copy all the settings individually through the tabs, bring that as one thing, then download it. It's not an internet speed problem. It's more rather the steps taken to ensure that it downloads all the settings. Just give it a minute or so. There we go. Now the file has been downloaded. Now you're going to use an app called VE Configure 3. That's the current version as of now. And then this app allows you have to download this separately, VE Configure 3, right? Now this app has just opened the file I recently downloaded. Now I'm going to go through the general tab, grid, inverter, charger, switching. This is where you configure how the MultiPlus must charge your system. What's your float voltage? What's your dynamic cutoff? The state of charge, cutoff power. So the grid, you will choose how many amps your grid supplies. Change the change of the current there. Click apply. Go to the grid. Where in the world are you? Select whatever country you are in. The password is usually 6 zeros if it's got a password protection. Go OK. Let's go there. Please correct me if I'm wrong on the 6 zeros. Choose the kind of inverter. What's the voltage input? Enter that there. What's your DC, low cut, and all that? Enter that. Don't make mistakes. Do you want to enable the charger in the MultiPlus? Yes. What's your charging variable? Enter that. What kind of battery are you using? Enter that there. Your visual switch, your assistant. This is very important for me. Some people don't need it. You can easily delete it, or you can add it. In fact, I sometimes even go as far as save assistants. For example, I could load one. See, there's my Sentinel. I always keep a saved copy because I don't want to lose the settings. I don't want to lose the settings. Load that up, and then I just give it a few seconds. There we go. I can start the assistant. When I run my own, you go load assistant, all assistants, go ESS, and then give it a name, then start going through it. Okay, we should just give it a second. Oh, okay, we kind of two SS. So let's just delete this one. There we go. Start there, go next. What kind of battery are you using? In my case, if you had a Victron system battery, Victron battery, you click that, and I'm using this one, my other type of BMS. Go next. What's the total capacity? Excuse me. What's your sustained voltage? What's your dynamic cutoff? What's your offset? Do you have any PV inverters? And then you're done. Then save it. This is why I had this one saved. And then after load it, move to the next one. Do you want to go through that? Do you want to enable this? This is very important. If you enable this part, the system will always prioritize other sources than the grid. For instance, it will always prioritize your car charger or your solar. If there's a little power that comes from there, it will always, this is important to save your electricity consumption. But if you disable it, it will go for whatever is available in a bulk mode and go for that first. Thereafter, when you are done with all this, close and then save the settings, right? As soon as you save the settings, come back to your portal, upload the file, select where you've stored it, double click it, and then it will upload the settings. It will go off and on. Your device will switch on and off, and then it will take all the settings you are running and apply that on your MultiPlus, right? Now let's go to the dashboard. This is the important part. Remember the grid that we spoke about? This is the grid coming into the system right now. 230 volt at 6 amp, and then it's on float mode now. This is the inverter here. These are my AC loads, right? This is where you see the weather, where I'm located, the forecast and stuff come from basically that. Thereafter, I've got my storage. This is my battery and my DC loads. I've got my solar panel that is currently disconnected now. I can scroll down and see a system overview of how the day was. This is a forecast of how the day would be. See, the time now is 10:39, but they show me how the day would go about. You can disable that. I could rather say I want to see the consumption, I want to see the solar, I want to see the battery, I want to see the solar forecast, and whatever you choose to display, and then that will all be here. And you can even go advanced. This is very important for me because I can easily say I want to see how tomorrow, what tomorrow's weather was looking like. This is a forecast, and then it'll show you how the forecast goes. You can always go to settings, general, scroll down, and then reset your focus. All right, reset your focus, go yes, and then come back to where we were, dashboard, and then it will reset all the focus, start from scratch, and create a new data analysis based on how things go. And the most important one is your consumption focus, because then it based on how you use the system, it's able to detect that during the day this is how much you draw, and this helps you balance as you target to maintain a good 100% state of charge. If you go to the far left, there's another space here that allows you to work around. Do you want your ESS assistant to optimize battery life, to keep the batteries full? So if you say I want to optimize this for battery life, it will sometimes drain the battery below 100, and sometimes recharge it again, and so on. And you can decide at what state should it kick back in. For instance, at 60% recharge the battery, or let it drain until 30, and then when it hits 30 recharge it again. I can also enable the relay. In my case, I've not connected this relay. You could connect a generator here, or a backup power source, that when it hits a certain state of charge, it must allow this relay to kick in, and so on. Yeah, basically that's that. The most important part is to be able to have a full system overview of how your system has been with regards to consumption, or the entire system, and you're able to see, okay, this is what the grid has delivered so far, this is how I've consumed power so far, and this helps you have a better understanding of how the other days could turn out based on real weather forecast as well. So today is cloudy, and it will also report that this tomorrow expect sunrise at such and such a time, and so on and so forth, right? Advanced is pretty much the same thing, that breaks down every single report, right? I can get reports from the grid. Every single report that comes from the system will be listed here. Just go through it. Very, very important. Every individual report, I would want to go through the MultiPlus. I need to see how the MultiPlus has behaved in the past hour, in the past 2 days. Battery, every single item that you find in advance. These are just reports as well. Device list, we've already gone through these items here. Remote console. This allows you to connect to the VictronConnect app. What you see here is basically what I was showing you earlier in the tablet, remember? And you see it's showing that there's a scheduled charge. The reason that is, it's because I went to dash, changed that. Remember, this was on keep batteries full. So if I say keep batteries full, confirm, and then go back to remote console, it's on float mode. It's a float mode. But why was that schedule charge there? If you go to settings, and then you go, these are also a list of, this is what you would find on your VictronConnect app on your phone. It allows you, the VRM portal also allows you to have a better view of how the phone looks. So I could go to my ESS settings and scroll down to where is that? It should be ESS storage. Is it? Yeah. And I could change that, remember that setting I just showed you a minute ago, and from that I can be able to schedule charge levels and when should the day, for instance, in a day I want the system every day to charge to 100% from such a time for such and such a period of time, right? And this is part of your ESS settings. Where did we set up the ESS? In the VE configure app. Remember when we said in the when we downloaded the configuration settings, right? One other thing that's very important, when you go to your DVCC, you can decide how much current your system is able to tolerate. In this case, I put 200 amps because the battery can handle that. But if you drop this to 50 amps, no matter what happens, no matter how much sun, how much grid is available, the system cannot pass the threshold, right? And same thing with the grid input. If you set this to say maybe 1,000 amps, even if the grid wants to give you more, it will not go beyond that point. But let's just dry run through this. You've got your brief connect, your brief layout, where you've got, okay, I need to attend the door, where you've got the grid coming in, where you've got the alternator, the sun, and state of charge. We've gone through this on the app actually. There's your overview, what's coming in and out. There's your levels, your tank, your environment. I've disconnected this as I was running the wires through the cable ties, but I'll plug them back. This is the DVR temperature, the battery temperature from the terminal, the entire nose cone, that little probe that was hanging there, and the fan controller. This is what blends the Sentry plus the other digital temperature controller. I'm not sure if you remember that. And there's notifications. If there's low battery, okay, I need to open the door. Okay, I will. If there's low battery, the system is experiencing some problems, you'll find the notifications there, and then you have your settings here. Then you go to devices. All these devices that you see here are the devices. Remember, I had to delete some. These are all the devices there. You can go through a particular device, just click on it, and then you still get further settings of that particular device, naming it and so on. When I say when we went through the device, I'll show you where that was. But you can check your internet connection, your VRM. This is where we are now. I've got full access on the VRM portal that allows me to access the VictronConnect app. Then you've got your system setup. You've got all these other I'm pressed for time now, you know. But okay, let's just remove the schedule there. We are going to go there. ESS. We are going to go there. Change. Keep batteries full, and then back again. We should be good. Now this is the VRM portal. Back to the VRM portal. That was a remote console, right? Now you can punch in a few of your notes here, passwords and stuff for settings, photos there, share what installation sharing. You want to share this with another person that will log in and also get to access. These are alarm logs, low temperature, low battery, everything will be logged. You see, low battery. This is me overloading, stress testing the system, and all those logs are still here. And in particular dates, on such and such a date, this is what happened. On such and such a moment, this is what happened. And then you can generate those reports, create a recurring report, economic reports, and then export them to see, are you saving money or are you wasting money, and how much of the grid are you using, and so on and so forth. Right, I can go up here, reports, hybrid, that's it, and then download a full PDF that will just show you everything, your usage and all that stuff. Where am I again? I'm here. So back, and then lastly, it's your settings. There's a setting I love here. It's called geofencing, which allows you to just go into your camper, and then if it's got GPS, for instance, you do have let's go add installation. What do you call this one global link, I think. This is important for boats, but even in the case of a camper, this is very important, because then you can geofence it to ensure that it doesn't move beyond a certain point. And now I intend to set my Cerbo as an alarm system, so as to allow me, as soon as maybe there's a certain zone bypassed, it will link that as an alarm system as well. There's your dynamic ESS. This is a very interesting setting. But yeah, after that you've got your teams, the groups managing the system, your GX files. We spoke about that earlier. You have got manuals, notifications, and preferences. This maybe you want this to run in a wallpaper mode, your profile, passwords, and all that stuff. It's important that you go through all that here. But sorry, man, I'm gonna leave a link of one of the guys that was very great, and maybe I need to talk to them first. But your matrix systems, which units do you use? That's about it. I really need to go.